Hello, welcome back. So in the last video we looked at how to derive a unit hydrograph using the adjustment factor method. So what we are going to do now is we are going to do a small assignment. What I have given you here is an actual event. So this is measured data on a small watershed in Indiana. So in this first table I have given you the discharge hydrograph, and this is the precipitation, and the event lasted the discharge lasted for 32 hours and the actual rainfall lasted for 2 hours. So this is what I have given to you, and the area of this watershed is 7.73 square miles. So let's follow the procedure that we discussed in the previous video on how to derive a unit hydrograph using the adjustment factor method. I also plotted the data for you just to see how it looks. So this is actually not a perennial stream, so it's a small creek, and you can see that we really don't have much base flow. But what we will do is we will just use this initial value of 5 CFS as our base flow, assuming that that was the flow that existed before the event occurred. So we will just use that constant value of 5 CFS. So again, there is not much to see here on the graphs. So very small value compared to what we have. So our first step is going to be to calculate the volume of the discharge or the direct runoff, and to do that we need to separate the base flow. So what we are going to do is, because we are going to assume a constant base flow of 5 CFS, we will subtract 5 from all the discharge ordinates to get the direct runoff. So this will be 5 minus 5, 0. So this will be 1066 minus 5, 1061. This will be 1783. This will be 1110. This will be 452, 283, 182, and so on. So you can fill the rest. So this is our first row, second row, third row, and fourth. Okay, so you can do the rest. So all we are doing to get the direct runoff hydrograph is to subtract a constant value of 5, which is the base flow, to get the direct runoff ordinates. So once you do that, you will get the direct runoff hydrograph values. Our next step then is to calculate this. So we just did this, so we subtracted base flow. Now what we are going to do is we are going to calculate the area under this curve and above base flow, and we have also learned how to do that. So I will just show you for the first 2 or 3 columns, and then you can do the rest. So as you know, we basically divide this into trapezoids, right? And then you calculate the area of each trapezoid. So for the first trapezoid, we will use these two values. So that will be 0 plus 1061 divided by 2 times delta t. So delta t in this case is 1 hour. So for 1 hour we will use 3600 seconds, because our flow is in cubic feet per second. And if you do this, what you get is the volume in cubic feet. So in this case it's 1909152 cubic feet. Okay, then we'll continue for the next. So what I can do is I can just say volume of DRH in cubic feet here. So volume DRH. So our first number was 190, so we don't have a 1909152. Let's do one more and then you know the drill. So for the next trapezoid we have 1061 plus 1783 divided by 2 times 3600, and that comes to 5118480 cubic feet. So 5118480 cubic feet. Okay, then you can do the same for all these other rows. Once you do all that, you get the sum of your DRH volume, and let's say that number is X cubic feet, and you divide the X cubic feet by the area of the watershed. So DRH depth is, let's say, so this will be DRH volume summation of all those values divided by area. So area in this case is, so volume divided by area is 7.73 square miles. So you need to convert that to feet. 5280 times 5280, and you will get some value in feet. Because the volume was in cubic feet, the area is in feet square, and then you multiply this by 12 to get DRH depth in inch. So after you multiply this by 12, you get the DRH depth in inch, and according to my calculation this comes to about 1.15 inch. And you can check after you do your calculations. So you can see that we are very close to a unit hydrograph. So if this was 1 inch, what we have here is a unit hydrograph, but this is little over 1.0. So what we are going to do now is, so the unit hydrograph ordinates is equal to DRH ordinates times 1 over 1.15. Okay, so what you will do now is you will divide these values 1061, 1783, 1110452 by 1.15. So if I do that, I'll just do for again just for few rows. So 1061 divided by 1.15. So this comes to 9. So this is 922.6. Let me do 1783 divided by 1.15. And that's 1550. And this is, so 1550.4. I'll just write one decimal, and then 1110 divided by 1.15. And that's 965.2, and so on. So you will finish that for all the, that should be here, 965.2. and this row will give you the unit hydrograph after you do all these calculations. And if you want, you can calculate the volume under that, and that should come to around 1 inch. Okay, so this is how you can get the direct or the unit hydrograph from the discharge hydrograph. So getting that hydrograph is one part of unit hydrograph. The second part is to get the duration of the unit hydrograph. So duration, okay, so to get the duration, what I will do is I will just plot the rainfall hydrograph that is given to us. So it's 4 pulses um, at half an hour time interval, and these are the values 0.1, 0.6, 0.6 and 0.1. So I'll just plot that here. So P delta T, so let's say this is 0.1, this is 0.6, 0.6, 0.1. Okay, now our direct runoff depth was 1.15 inch. Our total precipitation is 0.6 plus 0.6, that's 1.2, so it's 1.4 inch. So our loss is 1.4 minus 1.15, which is 0.25 inch. Okay, so in this case we have 4 pulses, so we can, so loss is 0.25 divided by 4 for each pulse. It's 0.0625 inch. And what you will do is, so 0.0625 is less than 0.1, so that will be somewhere here. So that's the loss of rainfall. And then this is our, oops, this is our excess rainfall. Okay, now again going back to this assumption that all the rainfall should be uniformly distributed. So in this case, as I said, this is an actual event, so we are doing our best. So even though it is not uniformly distributed across all the time steps, but as I said, sometimes you don't get that ideal rainfall event. So you can see the excess rainfall lasted for 2 hours, so the duration, and that 2 hour is basically the number of pulses that you have in your excess rainfall hydrograph. So in this case, this is 0.5 hour, so we have 4 of these in our excess rainfall hydrograph. So the duration of unit hydrograph is 2 hours. Okay, so what we have gotten here is a 2-hour unit hydrograph, and the unit hydrograph ordinates are the values that you have in these yellow highlighted cells. Okay, So I'm going to have you finish the assignment by filling out all the values for the unit hydrograph ordinates, and if you want you can check the answer. You can also fill out this row. So we calculate the loss for each pulse, which is this. So you will fill out this row by subtracting 0.0625 from all these values, and that will give you the excess rainfall ordinates of this rainfall hydrograph. So our end goal is to get the unit hydrograph. So the duration of that unit hydrograph is 2 hours, and the yellow highlighted cell will give you the values along the unit hydrograph. So this is one way of deriving a unit hydrograph. This is a simpler way compared to the next method that we are going to look at, which will be the convolution method. So in the next video we will see what the convolution method is and how you can use that to derive a unit hydrograph and also apply a unit hydrograph. So by now you know what unit hydrograph is, and you know one method to derive a unit hydrograph. So complete this assignment on your own. If you want, you can use Excel and get the values and fill out the answers on Blackboard. So with that, I will stop here and I will see you soon in my next video. Thank you and bye. And as always, if you have any questions, feel free to email me. Okay, bye.